we're going to work on the unit circle. So the question asks us, using the unit circle, determine the primary trigonometric ratios for 225 degrees. So there's much information we kind of have to get that out of the way first. First thing is we want our SOHCAHTOA, right? We need to know what the primary trig ratios are, and that's what these three are. So your primary trig ratios, our sine is the opposite over the hypotenuse, cos is adjacent over hypotenuse, and tan is opposite over adjacent. Unit circle is built off of a grid, so it's a circle on like the Cartesian plane here. Okay, and the circle, I'll do my best, we'll say that each is a half step. So the circle has a radius of 1 unit, in other words, 1. Okay, so its radius is 1, and that's why they call it the unit circle. It's 1 unit in terms of radius. But what we need to find out, and I'm going to erase that, we'll actually build an arm for this here so that we can manipulate it. Okay. What we need to find out is 225 degrees. So we know that we start from down here and we kind of go throughout the quadrants. 225 is going to fall in this quadrant. We know that from here to here is 90, here's 180, this is 270, and then all the way around would be 360 degrees. So we know we fall into here. We're not exactly where it is, okay? We can kind of figure out what the acute angle from the x-axis is, and that's what's going to be important. Once we have the acute angle, we can build a right angle triangle. So in order to do that, 225, we can subtract 180 from it to find out what the acute angle is. Okay, so we take 225 over 180 and subtract, and it looks like we get 45. So in other words, this angle here is 45 degrees. Okay, and that makes, whoops, not 40, 45. And that makes sense because up to this point it's 180, and then 45 more gives us our 225 degrees. Okay, so now we're going to build a right angle triangle from here. Now it might seem like we don't have a lot of information, but we know that this is a right angle triangle. We know that this hypotenuse is 1. Okay, that's because it's a radius of the circle, so the unit is 1. And because it's 45 degrees, that helps us build with special triangles also. Do you remember your special triangle rules?
Ooh, I remember some of them.
Okay, let's build the 2 of them and see which one.
Yeah, there was 2 of them, and then one was like root 3.
Yeah, so they're special triangles that essentially deal with 2 types. They're both right angle triangles. One of them deals with angles that are 45 degrees, which is obviously what we're going to be working with. And then there's another one that deals with 60 degrees and 30 degrees. Now, what's good about this one is it's set up with the numbers 1 and 2. And the idea is that if this is 1 and this is 1, then this is root 2. For our other one, it's dealt with the numbers 1, 2, 3. Okay. 2, again, is the hypotenuse. It's, sorry, not root 2, but 2. Okay, 2 would be the hypotenuse. So this is kind of information you want to memorize. And then this value is 1, and this value is root 3. We know root 3 is bigger than 1, so it's opposite of the 60 degrees. What's important about them is you can build similar triangles from them. So we have a similar triangle within here. It's not exactly a hypotenuse of root 2, but what we have is one, we'll redraw it. It's got 45 degrees, but the hypotenuse in this one is only 1. So because they're both 45 degrees, we know this is an isosceles triangle, this special one. So these 2 are the same, which makes sense, hence they're 1 and 1. Mm-hmm. So we can use our similar triangle rules. Well, how do we go from root 2 to 1? Well, we're shrinking, so we're dividing by root 2. Yeah. Okay. So whatever you do to one side of a similar triangle, we do to the other. So in order to figure out this side, divide by root 2, 1 by root 2, and 1 over root 2. Okay. So now that we have that information, okay, we can build our trigonometric ratios for sine of this angle, cos of this angle, and tangent of that angle. Okay. The only other important piece of information we have is the cast system. We have to know that which is positive and which is negative. So we're in, this is quadrant 1, 2, 3, and 4. So because we're in quadrant 3, okay, tangent is positive. Okay, so we know that our tangent is going to be positive. We know our cosine is going to be a negative value, and our sine is going to be a negative ratio. So the ratios will be negative in there. And this kind of makes sense, and I can show you how this will make sense. So let's kind of write these in, 1 over root 2. I guess I should have made it a little bigger since this is our diagram. Those are the measurements we have now. So we're saying that part of the triangle is 1 over root 2, and this is 1 over root 2. I'm going to redraw it so we can build these, and then I'm going to draw a reference to this to explain why they're positives and negatives. So we have our triangle here. Sine theta, so it's 45 degrees, we know it's 45 degrees, is equal to, and which is the opposite over the hypotenuse. Well, opposite of any of the 45s is 1 over root 2. Okay, so you have 1 over root 2 over the hypotenuse is 1. Well, anytime we divide anything by 1, you just end up with whatever number's on top. So we don't really have to do that. We can kind of leave it like this. And what's going to happen, I'll redraw it so it looks a little nicer. So it's 1 over root 2, because when we divide that by 1, it doesn't change anything. If you notice, that's essentially the original triangle we have. Opposite of it over hypotenuse is 1 over root 2. So a similar triangle worked out. Cos of 45 degrees is equal to adjacent over hypotenuse. You end up with the exact same thing, 1 over root 2, right? It doesn't matter which of these 45s you're working with. The adjacent is 1 over root 2. The hypotenuse is 1. When you divide by 1, it doesn't change anything. And then tangent of that 45 degrees is the opposite over the adjacent. So we're talking about 1 over root 2
over 1 over root 2
over 1 over root 2, which is essentially just the value of 1. It ends up as 1. And that makes sense here because it's 1 over 1. It equals 1. So those are nice. But like we said, remember we said that this was going to be negative, negative, positive. Okay?
Yeah.
Let's make sense of that. Can I zoom in a little? I think I can. Zoom 100? Nope, that's not a zoom. Go back to the page width. Okay, we'll just leave it as it is. Okay, so this is the angle we're talking about, right?
Mm-hmm.
Well, think of this as a Cartesian plane where this is your x and your y, and they're both positive in that quadrant. In this quadrant, you have a negative x and a positive y, okay? In your tangent quadrant, you have a negative x and a negative y. Everything in quadrant 3 is like that. And in quadrant 4, you have a positive x and a negative y value, okay? So any coordinates in there are going to have these types of relationships. So that being the case, okay, we can actually give this a coordinate. This coordinate here, we can say is negative 1 over root 2. Yeah, and negative 1 over root 2. Okay, so with that information, that's a negative and that's a negative, right? Because we're going back and we're going down. So for sine is opposite over hypotenuse. So we have a negative over a positive. We always assume the radius is a positive. So negative divided by a positive is a negative value. For cosine, the adjacent divided by the hypotenuse, we have a negative over a positive. So you have a negative again. And for tangent, you have a negative divided by a negative. Well, that ends up being a positive. So that's why those relationships are happening in those quadrants.
All right.
Okay?